The way we move is broken. Our roads are clogged with traffic, our skies with carbon-spewing aircraft, and our oceans with slow, fuel-hungry shipping giants. And yet, while most of the world keeps staring at traffic reports and delayed flights, a quiet revolution is happening. In underground labs, desert test tracks, and boardrooms funded by billionaires, engineers are crafting the future of transportation, technologies that will fundamentally change how we move, trade, and live. Hyperloop, skypods, ocean trains. These aren't distant fantasies. These are real systems, being built right now, tested in multiple countries, and backed by governments and corporations alike. And together, they promise something humanity has never had before: a planet where time, distance, and geography no longer matter. So today, we'll journey into that future, one innovation at a time. Let's begin with the fastest of them all. Back in 2013, Elon Musk casually published a white paper that dropped like a bomb across the world of transport innovation. It described a new system of transportation: a pod inside a sealed vacuum tube, hovering on magnetic rails, capable of hitting speeds over 760 miles per hour, all while using less energy than a plane and producing zero direct emissions. This is Hyperloop. Now, over a decade later, companies like Virgin Hyperloop, Heart Hyperloop, Zeleros, and even India's DGW Hyperloop are racing to bring this vision to life. Here's how it works. Inside a near vacuum tube, air resistance is almost entirely eliminated. The pods levitate using magnetic levitation, or maglev, meaning no friction with the ground. The result? Unprecedented speed, with almost no energy loss. A trip from Los Angeles to San Francisco? Just 35 minutes. Amsterdam to Berlin? Just over 40 minutes. But this isn't theory anymore. In November 2020, Virgin Hyperloop successfully conducted the first human trial at their Nevada test site. Passengers reached over 100 miles per hour in just a short test tube. That may not sound like much until you realize it was just the beginning. The big challenges now? Infrastructure cost, safety certification, and land rights. Building massive tubes across continents isn't cheap. But with support from governments, the European Commission, and the Gulf states, the first commercial routes are already in advanced planning phases. India's Pune-Mumbai route could be operational within the next decade, cutting travel time from 4 hours to just 25 minutes. And this is just the start. Because Hyperloop isn't just about speed, it's about redefining interconnected mega-regions. Suddenly, you could live in one city and work in another 400 miles away, with a commute faster than driving across town. It's the start of a post-geographic civilization. Now let's look up. Our cities are suffocating. Traffic congestion isn't just a nuisance, it's an economic disaster. The average US commuter loses nearly 100 hours per year stuck in traffic. In megacities like Manila, Mumbai, and Sao Paulo, that number's even worse. But what if we simply rose above it? Enter skypods, small, electric, AI-guided vehicles that float across cities using elevated tracks or suspended cables. The future of urban transport isn't just autonomous, it's aerial. Companies like Skytran, a NASA spin-off, USKY Transport in the UAE, and Skyway Technologies in Belarus are building suspended pod systems right now. These are not your grandpa's gondolas. Skypods are fast, capable of speeds up to 150 kilometers per hour, 93 miles per hour. They're scalable, able to handle thousands of passengers per hour. And they're energy efficient, running on solar or grid electricity. Dubai, ever the futuristic playground, is already working to integrate skypods into its smart city vision, aiming to replace 30% of road traffic with autonomous transport by 2030. Unlike buses or trains, skypods are on demand. You don't wait for them, they wait for you. They use AI to group passengers by destination, optimize traffic on their own network, and deliver a seamless door-to-door experience. And best of all? They don't require tearing cities apart to install. Their elevated tracks can be built above existing roads, meaning far less disruption and far lower cost. Now imagine this. You step out of your apartment, walk to a rooftop station, hop in a pod, and arrive at work 10 minutes later, without traffic, without carbon emissions, without stress. This isn't sci-fi. This is already being tested in Sharjah, Singapore, and parts of Central Asia. It's the rise of the 3D city, where movement isn't bound to the ground anymore. Now, we dive. Because the final frontier of transport innovation isn't above ground or in the sky, it's beneath the oceans. Ocean trains, yes, you heard that right, are massive underwater high-speed rail systems designed to connect entire continents through submerged tunnels. At first glance, it sounds insane. But just consider this. In Japan, the Seikan Tunnel connects Honshu to Hokkaido beneath the sea, stretching over 33 miles long. In Europe, the Channel Tunnel runs under the English Channel, linking the UK to France. Both are fully operational, and have been for decades. So now, engineers are thinking bigger. Much bigger. China has proposed the Trans-Pacific High-Speed Rail, connecting mainland China to the United States via Siberia, a subsea tunnel under the Bering Strait, and Alaska. Cost? Estimates start at $200 billion. But the strategic potential is staggering. Not just for passengers, but for freight, trade, and geopolitics. Imagine bypassing hostile sea lanes entirely, or delivering goods faster than cargo ships without relying on fossil fuels. Japan's Chuo Shinkansen, the world's fastest maglev train, has hit 603 km per hour, 375 miles per hour, in tests. Now imagine that same tech deployed in a vacuum-sealed tunnel under the Pacific Ocean. Travel from Tokyo to Seattle in under 4 hours, with zero emissions. Of course, there are immense challenges: deep-sea engineering, tunnel pressure resistance, seismic safety, international cooperation. But the building blocks are already here. The technology exists. The political will? That's what needs to catch up. Now picture this future. You wake up in your vertical apartment in Dubai. Step into a skypod. It whisks you above traffic to the Hyperloop terminal. There, you shoot across the desert at the speed of sound to a coastal hub. A final transfer puts you on an ocean train bound for India, Japan, or even the western United States. No airports. No highways. No borders in the traditional sense. Just seamless, intermodal, global movement. The real beauty? All of this can run on 100% renewable energy. Skypods powered by rooftop solar. Hyperloop driven by solar panels on its own tubes. Ocean trains connected to hydro and geothermal power. This isn't just about speed. It's about sustainability, accessibility, and freedom. But there's one problem: none of this is guaranteed. If we don't act, we'll stay trapped in the 20th century, paving more roads, expanding more airports, and watching our planet choke on the emissions of outdated transport. But if we choose to build, if we invest in vision over convenience, if we reimagine infrastructure not for the next 5 years, but the next 50, we could leave traffic jams and jet fuel behind for good. The future of transportation won't be one invention. It will be a network of networks, ground, sky, and sea, all connected by AI, powered by clean energy, and designed not to serve a few, but to move everyone. It'll be faster, cleaner, smarter. But more importantly, it'll be fairer. Because when transportation gets better, everything gets better: access to jobs, healthcare, education, family. And the freedom to live wherever opportunity exists, not just where roads allow. So the question isn't whether this future is possible. It's whether we'll build it. Thanks for watching Futuristic Edge. Hit subscribe if you want to stay ahead of the curve. Because this isn't sci-fi. It's the next stop on our journey as a civilization. And it's coming fast.